All right, welcome to Mercer Senior Project. This year, Mercer completed a year-long internship with Positive Energy, which is a consulting group here in Austin. During this time, they assisted in the development of a software tool. They performed background research since this was a new content area for them. They learned how to work with an industry, including communicating, working with company software requirements. They researched the best software solutions for visualizing the data that Positive Energy needed, and they met frequently with engineers to give updates and final presentations. This year's just been a total honor working with Mercer, witnessing their courage and growth and working in a brand new content area, learning to navigate a corporate environment, and working on a team with other engineers. Let's give it up for Mercer.
Alright, so I'm Mercer. I interned at Positive Energy. And what I made is a tool that helps to visualize home carbon emissions over up until about 2050. So it took a little bit to get to that project. First, I had a few smaller projects before I got to that final state. So yeah. Oh, hold on. I'm not connected to the internet. There we go. So one of the first projects that I did was I added visualizations to an already existing tool. That tool was an enclosure tool, which helped engineers and clients see where their building was at in terms of meeting code requirements and what's known as positive house requirements, which is basically like how environmentally friendly is your house. So it kind of provides a more visual aspect rather than just looking at numbers and seeing where you're at. So that's what my tool added onto it. And throughout that process, I drafted some graphs. That bottom one is what ended up being the draft for the previous tool. And it ended up being pretty similar. These drafts were notes from meetings that I had with the company, so I was just jotting down graphs that I thought might work based on conversations that we were having. The graph above is what ended up being kind of similar to the prototype for the home carbon emission visualize. Yeah. So before we get into stuff, I had a lot of issues that I encountered. One of the biggest ones was I was working in this text editor called Google Colab, and this was because for the first part of things, I was having the other intern that worked there kind of give me a little bit of a place to start. And Google Colab has this cool feature where you can work in tandem at the same time on some code. So he would put in a little comment on what I should work on, and then I would fill out the code. And I learned how to use this text editor and do all the stuff for it. And then when I finally got to creating the tool, it could not have a GUI component, which is like the graphical user interface, because of the way it worked. So I had to scrap that and move to a different text editor. Another issue that I ran into is when I was packaging it all up as an exe file, which is like a little executable that you can run on any computer, regardless of if it has Python installed or any of the package dependents on any computer. It was being recognized as malware, which was really fun because it is not malware. And I had to find workarounds and find ways to be like, Windows Defender, it is not malware. And that was a fun little trial and error moment. I learned a lot of skills too. I learned Google Colab. I learned how to reference Google Sheets from Python, so that came in useful when referencing this database that my code is based on, which I'll get into in a little bit. I learned how to package as an executable. I learned how to integrate matplotlib with tkinter. Matplotlib is a visual package which is used for graphing within Python, and tkinter is the package used for a graphical user interface. So when integrating the two, they tend to cause bugs. So that was a little bit of a learning curve. Converting XLSX files to databases is like the groundwork for data science, which is the field I want to go into. And learning how to do that was a difficult skill, but it was something that was really fun and interesting to me. I really honed in my debugging skills because I encountered a lot of bugs that weren't on Stack Overflow or weren't covered anywhere on the internet. And I just had to like keep plowing through it on my own. And I really worked on my communication skills because I had to talk a lot with a lot of different people at Positive Energy, and I had to work through my anxiety and be like, I need to talk to someone. I just have to do it regardless of how I feel about it, and reach out anyway. So, yeah. So my home carbon emission visualizer. What does it do? It can measure the predicted carbon output of a house for 26 years, so up until 2050. It factors in many different conditions, such as the location of the home, how much it's going to cost to decarbonize the US grid, and more. We'll see more of it when I actually do a little demo of it. This is an output of what it looks like. One of the features of the tool is you can save the graphs that it outputs as a PNG within the tool. So this is one of the things it does. So some background information. It is technically carbon. It is CO2e, which is a way of measuring greenhouse emissions in terms of carbon dioxide. So it is more comprehensive than just measuring the carbon dioxide output. So it's carbon dioxide plus things like methane and other emissions. And then my backing data, the data that provides the emission factors. So how much the grid is putting out is provided by Cambium's Elmer dataset by NREL, and those are some acronyms. So Cambium is just a word. Don't worry about that one. NREL is the National Renewable Energy Laboratory, which is run by the United States government. And Elmer is a long-run marginal emissions rate study. So that's my backing data. It is done every year. So this was the 2022 version because as I was doing it, the 2023 one was not out yet. It was put out about halfway through my process, and I was not going to switch over in the middle. So the grid is broken up in a little special way inside the Cambium dataset. This is it. It's similar to eGrid if you're familiar with that. I'm pretty sure everyone's familiar with ERCOT because of the incidents. But the US government splits up the energy grid, and it's very similar, but outside of ERCOT, the US energy grid is very fluid. So some locations pull more energy from other locations in the grid. So Cambium adjusts for this, and their regions are a little bit different. So that's what that is. And then the last other thing that I'll get into is I learned how to write good comments. This was my comments before I started doing things. It was mainly just things to like jog my memory when I would look back at it and be like, oh, what was I doing? And for those of you who don't do a ton of code, the little hashtag with the green text is what a comment is. And then after, I go into more explaining why I'm making the choices that I'm doing and what the information is. So, yeah. Now, we're gonna do a demo of the thing. I got a hold of Griffin's annual kilowatt hour usage. So we're gonna see Griffin's usage. Okay, so this is the tool. Our zip code is 78751. Our and then this is an optional thing. You can put in a reduced load to show like a client of what their house could potentially look like. So I'm just going to put in potential 1. And then you can do how much renewable energies are going to cost. So I'm going to do a mid case because it has an interesting thing in Texas that I'll show. And it takes a minute, you can see the calculations running. So up on over here, you can see this is how many pounds of CO2e we put out a year. So that's 25,000 pounds of CO2e from Griffin every year. And that drops all the way down to 5,000 in 2030, but it jumps back up. And this is because, for some reason, Cambium, inside their data, they are projecting that in the process of decarbonization, we are switching to a different energy source that produces more greenhouse gases than expected. And this is a Texas-specific issue. So if you look at other zip codes, this spike doesn't happen. And I thought that was interesting. So I thought I might also show a location that wasn't Texas to show how much better it is. 8, 0, 3, 9. So this is Seattle, which has one of the best energy grids. So it starts out higher, but they are decarbonizing much faster, and they go down to much lower values. And California goes down to even 0. And then for my last thing, I will show an average home. And then I guess I'll show you don't have to put it reduced. Show all the functionalities of the graph. So if you don't include the reduced load, it removes the tick mark from the plot and the line. This is a high cost case, and it's already significantly less. And the one other thing that this tool can do is you can save it as a PNG. Name it whatever you want, and you can just save it. Yeah. All right.
Has 1 minute left.
Yeah.
So does anybody have a question? Just like 1 minute left.
What's the intended user of the tool?
It's supposed to be used in tandem between both engineers and architects, and also the engineers and clients.
What's the cost of it?
The cost of
Installing that and to read a home.
for like the annual energy kilowatt hour, I'm not sure. That wasn't a part of the company that I'm.
I have one more question. So Texas showed a pipe in carbon dioxide emissions.
Yes.
Because we're using coal and natural gas right now. What could they use with result more carbon dioxide?
I'm blanking on it. It was.
I'm just
Can
wondering
I-
what it would be.
Get back to you in
Yeah, sure.
environmental science.
Yeah,
I have the graph saved on my
no,
computer.
perfect, no.
How does it save the graphics?
That uses the OS package in Python. So it's a function within the OS package.